Welcome to Digital Learning DCE. Myself Dr. Shailaja Young, Assistant Professor, Department of Mathematics, Government First Aid College. In this video, let us learn the chapter matrices. Under this, the theorems on rank of a matrix and row-reduced echelon form. The objectives of this session is understanding the effect of elementary transformations on the rank of a matrix and understanding the concept of row-reduced echelon form. By the end of this video, one can be able to understand the importance of elementary operations in finding the rank of a matrix, and they learn the concept of row-reduced echelon form and applying that to the given matrices. The effect of elementary transformations on the rank of a matrix. Theorem 1. The rank of the matrix does not alter by interchanging any two rows of the matrix. That is, by interchanging any two rows, or it can be two columns, the rank of the matrix does not change. So let us prove this. So let capital B be the matrix obtained by interchanging the ith row and jth row of the given matrix A. Let B not be any submatrix of order R plus 1 of the matrix B, and its correspondingly placed submatrix of order R plus 1 of A be A naught. These two submatrices will be one and the same, except the two identical rows are interchanged. That is, ith row is interchanged with jth row in B naught. Since A naught and B naught have two rows interchanged, therefore the determinant of B naught is equals to minus of determinant of A naught. Since the rank of A is equals to R, therefore the minor of order R plus 1 vanishes. The determinant of A naught equals to 0, hence the determinant of B naught is also equal to 0. This implies that every minor of order R plus 1 of B vanishes. Therefore, the rank of B is lesser than or equal to R. That is, the rank of B is lesser than or equal to rank of A. Let us call this as equation number 1. Similarly, by applying the same argument on the matrix A, we can show that the rank of A is lesser than or equal to rank of B. So we'll call this as equation number 2. From equation 1 and 2, it follows that rank of A is equal to rank of B. Therefore, if we interchange any two rows of a matrix, the rank of the matrix does not change. Similarly, even if any two columns are interchanged, then also the rank of the matrix remains same. The other statements of effect of elementary transformations are the rank of the transpose of a matrix is same as that of the original matrix, and multiplication of the elements of any row by a non-zero number does not change the rank of the matrix, and addition to the elements of a row, the product by any number k of the corresponding elements of any other row does not change the rank of the matrix. Row reduced echelon form. A matrix capital A of order m cross n is said to be in row reduced echelon form if the leading element of each row is unity. It means it should be 1. All the entries below this leading entry is 0. The number of zeros appearing before the leading entry in each row is greater than that appears in its previous row. The 0 row must appear below the non-zero rows. For example, the two examples are given here. So the first one is 3 cross 3. It is 1, 2, 3, 0, 1, 2, 0, 0, 0. Here we can observe the first row, first element, the leading element is 1, and then below 1 the entries in the second and the third rows are 0. Then after 0 in the second row, the next leading entry is also 1, and the 0 row is placed at the bottom, that is the third row. The one more example for the row reduced echelon form is 1311 0140 000. So here also we can observe that the leading entry, the leading element in each row is unity, that is 1, and the 0 row is placed at the bottom. Example. Let us reduce the matrix 1, 2, 3, 2, 4, 7, 3, 6, 9 to the row reduced echelon form. So for the solution, consider the matrix 1, 2, 3, 2, 4, 7, 3, 6, 9. Let us apply the operations. R2 changes to R2 minus 2 R1 and R3 changes to R3 minus 3 R1. So by applying these operations, we can obtain the matrix with the elements. The first row elements R1 remains as it is 1, 2, 3. In the second row, it is R2 minus 2 times of R1, that is 2 minus 2, it becomes 0. 4 minus 4 becomes 0. 7 minus 6 is 1. And the third row, that is R3 minus 3 times of R1 gives us 3 minus 3 0, 6 minus 6 0, 9 minus 9 0. So here what matrix we have obtained it is in the row reduced echelon form, because the 0 row is at the bottom and the leading entries in the other two non-zero rows are 1. So therefore the rank of this matrix is. Let us discuss one more example. Reduce the following matrix to the row reduced echelon form. The matrix is of order 4 cross 4 and it contains the elements 1, 2, minus 2, 3, 2, 5, 4, 7, minus 1, minus 3, 2, minus 1, 2, 4, minus 1, 3. In this matrix, the leading entry of the first row is 1. Therefore, there is no need of changing the first row elements. Below this 1, we can see 2 in the second row, minus 1 in the third row and 2 in the fourth row. So now our aim is to make these three leading values below 1 to 0. So let us apply the operations. R2 changes to R2 minus 2 R1 and R3 changes to R3 plus R1 and R4 changes to R4 minus 2 R1. So our purpose is to make the elements below 1 as 0. This results gives us 1, 2, minus 2, 3. The next second row changes to 0, 1, 8, 1. Third row changes to 0, minus 1, 0, 2. And the fourth row changes to 0, 0, 3, minus 3. Now we can have a look in the second row. After 0 we have 1. Therefore no need of changing that element. So let us apply the operation to the third row, that is R3 changes to R3 plus R2, because now our purpose is to make the element below this second row 1 as 0. That is in the third row let us make minus 1 as 0 by applying the transformation R3 changes to R3 plus R2. This gives us the matrix equivalent to 1, 2, minus 2, 3, 0, 1, 8, 1, 0, 0, 8, 3. Then the fourth row remains as it is 0, 0, 3, minus 3. Now in the third row, the leading entry after zeros is 8. So our purpose is to make it as 1. Therefore, let us divide the row 3 elements by 8. That is R3 changes to 1 by 8 R3. That gives us the matrix with the elements 1, 2, minus 2, 3, 0, 1, 8, 1, 0, 0, 1, 3 by 8 and the fourth row 0, 0, 3, minus 3. Now you can look at the first 3 rows are already in the echelon form. So now our purpose is to reduce the fourth row. So by applying the operation, R4 changes to R4 minus 3 times of R3. By applying this, we can make the element after zeros as 0. That is the fourth row. The first three rows remains as it is. The fourth row changes to now 0, 0, 0 minus 33 by 8. So now our purpose is to make the fourth row, the leading element of the fourth row as 1. That is by changing the R4 to minus 8 by 33 into R4, we can obtain a matrix 1, 2, minus 2, 3, 0, 1, 8, 1, 0, 0, 1, 3 by 8, 0, 0, 0, 1. So we can look at this matrix. We have 4 non-zero rows. Hence, this is the row reduced echelon form and the rank of this matrix is 4. And the reference books used for preparing this video is given in this slide. You can go through it, and thank you for watching this video.